This particular problem is going to take you through examples from section 2.4 and 2.5, which talks about all the different types of forms of equations of lines. We're going to go through all three: point slope, slope intercept, and standard form. So I'm going to show you how to go and interchange between these two forms. So the first thing we're going to do is we're going to start off with a point with 2 points, 1, 9, and 4, -2. Well, in order to do point slope, which is where we're going to start, I need a point and I need the slope. Well, I actually have 2 points to choose from, so that criteria is met. But I need my slope. So the first thing we have to do is find our slope. Well, the slope formula is y2 minus y1 over x2 minus x1. So if I'm going to call this point 2, I would set up -2 minus 9 over 4 minus 1, which gives me -11 over 3. So my slope is -11/3. Once you find the slope, you can pick either of the 2 points that you want. I'm going to pick the 1, 9 because there are no negatives. Sometimes that makes it easier. So my point slope would be y minus y1, which is 9, equals my slope, which is -11/3, times x minus x1, which is 1. If you were doing a problem in my math lab and they asked you to put an equation in point slope form, this would be your answer. There's nothing else to do. If you simplify it any further, you're putting it in a different form. So this is my answer for point slope. Now I'm going to go into slope intercept form. Now to go from point slope to slope intercept form, I'm going to actually take this equation and I'm going to do my distributive property and solve for y. So the first thing I'm going to do is distribute my -11/3. So -11/3 times x is -11/3 x. -11/3 times -1 is +11/3. Okay, then I'm going to add my 9 to both sides of my equation. So I get y equals -11/3 x plus 38/3. Okay, if you're not good with fractions, you can always do that adding in a calculator just by adding 11/3 plus 9. Of course, 9 is 27/3, so then you can just add the numerators. Either way, as long as you get that your y-intercept is 38/3. Okay, so that is my simplified answer for slope intercept form. Okay, now we're getting into standard form. Standard form is a little bit tougher, and it involves a matter of 3 different steps. Okay, the first step for standard form, I'm going to do this first. The first step for standard form is to get x and y on the same side. Now that means to get them on the same side of the equal sign. Okay, so if I take my problem, y equals -11/3 x plus 38/3. First step in standard form is to move this x term to the other side so that x and y are on the same side. In order to move it, I would add it. So I'm going to get 11/3 x plus y equals 38/3. That's step 1 of converting to standard form. Now, step 2 is to make sure that x, or your x term, is written first and that it is positive. Okay, so make sure that the x term is written first and that it is positive. Well, if you look back up to our problem right here, I went ahead when I moved it, I went ahead and put it first, and it's already positive, so I don't have to worry about that. If it had been negative, the way you fix that is you would change all of your signs. Okay, so step 2 we don't have to do here. And then step 3 is to eliminate fractions, or for that matter, decimals. Okay, so you cannot have any fractions or decimals. Most of the time it's going to be set up as fractions, so you want to eliminate your fractions. Well, this goes back to the problem that I showed you how to do in section 1.4. In order to eliminate fractions, you have to get the LCD. Luckily with this problem, there's only one denominator, so the LCD is going to be 3. So I'm going to take this problem and I'm going to multiply everything by the LCD, which is 3. What that's going to do is it's going to eliminate my fractions. So here my 3's cancel, and I get 11x. Then when I do 3 times y, I get 3y. Then when I do 3 times 38 over 3, the 3's cancel again, so I end up with 38. This is my answer in standard form. So we took this one problem and worked through all the 3 forms of equations of lines.